Assalamu alaikum. Good afternoon and welcome to AGU. So my name is Osman Ahmed. I will introduce myself, brief introduction so you know who is talking to you. So as I said, my name is Osman Ahmed. I'm originally from Sudan. I studied medicine and I have graduated from University of Khartoum in 2006. I think most of you at that time was in primary school probably, or yeah? Yes. Osman, yes. And so I studied medicine. Okay guys, I studied medicine, graduated 2006. And then I work in University of Khartoum as teaching assistant in the Department of Biochemistry. And I studied master in medical biochemistry. And in 2012, I moved to Sweden, and I have done my PhD in clinical chemistry in 2019. And after that, I get a fellowship at Karolinska Institute in Sweden. I just finished in 2023, and I just joined the AGU as assistant professor in the Department of Medical Biochemistry. So today, I'm going to talk about basic stuff of the different constituents of the atoms. We're going to talk about chemical bonds and also about the chemical reactions, how different molecules interact, and different types of reactions, of chemical reactions. So these concepts and knowledge are very crucial and essential to understand when we talk about lipid, carbohydrate, and proteins. So this basic knowledge about the chemical reactions and the atoms is very essential. So first, we'll talk about the different constituents of the atom. We call it subatomic particles. So within the atom, we have different particles. So we have protons, electrons, and neutrons. So also, sometimes we have what we call it positrons. So the protons in general, they are type of subatomic particles which have positive charge. So the symbol for proton is B plus. So this is for the proton. The protons, they usually found within the nucleus of the atom. So they are within the nucleus of the atoms, and they have bigger mass of 1 atomic mass unit. When we measure these particles, we measure them with what we call it atomic mass unit, AMU. So each proton have a mass of 1 atomic mass unit, and it have a positive charge. The other subatomic particles called electrons. So the protons found inside the nucleus, but the electrons found outside the nucleus. There is the layers, we call them shells, outside the nucleus, and the electrons are found there. And oppositely to the protons, electrons can move freely and constantly between different layers when they absorb energy and when they emit energy. But the protons are constantly found within the nucleus, and that's why the atomic number of each atom is depend on the number of protons that found within the nucleus. The weight of the electrons is far smaller than the protons. As we said, for the protons it is 1 atomic mass unit, but here the weight is about 1 over 1800. So it is very small compared to proton. We have a third subatomic particles. We call it neutrons, and from the name, it is neutral. The symbol is N0 because it has no charge. And it's found also within the nucleus. So we have three. We have the protons and neutrons within the nucleus. The protons have a positive charge. The neutrons have a positive charge. They are bigger. Both of them have a mass of 1 atomic mass unit. And we have the electrons, which are in the outer layers. They are outside the nucleus. They can freely move according to the energy they absorb or the energy they emit. The fourth type is the positrons. It's called anti-electronic or anti-particle. It's completely different from the others, and it doesn't exist in ordinary matter. It usually exists in unordinary occasions, but it has the same mass of the electron, but positively charged. So the take-home message from this slide is to focus on the three major components: the electron, the protons, the neutrons. So here are different types of different atoms. So as you can see here, we have the hydrogen. Hydrogen has one proton, which is inside the nucleus, and one electron outside. So you can see that so in the hydrogen, you can see that we have one proton and neutron, and we have one electron. The first layer of the atom, we call it the K shell. So we will talk about different kind of shells in the upcoming slide. So usually we have equal number of electrons and proton. So for the hydrogen, it is 1. For the carbon, we have 6 proton, 6 neutrons, and we have 6 electrons. But the distribution of electrons outside the nucleus is depend on in which shell we are talking about. So usually in the first shell, we have 2 electrons. So the capacity of the first shell after the nucleus is only 2 electrons. The capacity for the next one is 8 electrons, but here, because for the carbon atom, we have only 6, so we will have 2 electrons in the first shell, and then we will have 4 in the second shell. But the second shell can accommodate up to 8. For the nitrogen, it will be, as we said, the same. We have 7 proton, 7 neutron, and we have 7 electrons, 2 in the first shell, 5 in the second shell. For the oxygen, which have atomic number of 8, we'll have also 8 proton, 8 neutrons, and we'll have 8 electrons, 2 inside in the first shell and 6 outside. If we go further for a larger molecules, for example, the phosphorus, it have 15. The atomic number for phosphorus is 15. So that means we have 15 proton and 15 neutrons within the nucleus. But the distribution of electrons is, as we said before, different. In the first shell, we will have 2. The second shell, we will have 8. So the total is 10. In the third one, because the second shell, the capacity is only for 8. So it cannot accommodate more than 8. Then we will need a third shell, which will accommodate 5, because 2, 8, 5. For the sulfurs, it will be 2, 8, which is 10, and then 6, because the atomic number for the sulfur is 16. So this is basically how the protons and neutrons and electrons are arranged within the atom. The understanding of this concept is very important to understand how these atoms interact with each other. the basic definition of energy is the ability to do work. So the ability of doing work is called the energy. So as I said from the beginning, protons are constant, they are within the nucleus. Electrons, they constantly move between different shells. So we can see here that we have the nucleus. The first shell, we call it K shell. The capacity is 2 electrons. The second one is L, and the capacity of the second shell is 8. The third, called N shell, 18, the capacity. Then we have N shell, 32, O shell, 32, and we have B shell, 18, and the Q shell, 2. So each atom can have this much of layers or shells. So the number of shells and number of layers, it depends on the atomic number, and it depends on the number of protons within the nucleus. So electrons of similar energy are arranged in energy shell within the atom, as we said, 2, 8, 18, 32, 32, 18, until 2. Usually, the electrons with the least energy, with the lowest energy, they are usually found within the K shell. So they are the closest to the nucleus. So the electron with the lowest energy, they found closest to the nucleus. And the electrons with the higher energy, they are found farthest from the nucleus. So what happens for the atoms? It can absorb the energy. So the electron can absorb energy from the surroundings, and it became in excited state. So it can move from the nearest of the nucleus to the outer. So that's why what we said in the beginning, that electrons are moving between different shells. And this movement depends on the energy that they absorb. If they absorb energy, they will have more potential energy. They can jump in the shells from the nearest to the nucleus to the outest. And the opposite also can happen. When they emit the energy, when they give energy away, they will lose energy, so they will jump from the outest, since their energy potential will be lower, so they will jump from the outer to the inner. So the movement of the electrons is depending on the energy. So we can see here that with the absorption of energy, the electron can move to the outer shell, and with the emission of the energy, the electron can go to the inner shell. So electrons with higher potential energy are located in shell further from the nucleus, and electrons with the lowest energy amount, they are found in the K shell, in the closest shell. And as I said, electrons absorbs the energy and jump to a higher energy level. So it's just the movement is depending on the energy. If they absorb energy, they go away with a higher energy potential. If they emit energy, they lose energy, the potential energy become lower, so they jump. So this continuous movement of the electrons, what make the atom reactive. So why the electrons are like moving around, and why all these different things are happening? So for atoms with more than one shell, we have what we call it octet role. So the outer shell is stable when it contains 8 electrons. So usually the atoms is seeking for stability, and it becomes stable when it has 8 electrons in the outer shell. So when the outer shell is with the full capacity. And the element gain or lose electron to attain an electron configuration of the nearest noble gas or inert gas. اللي هو بالعربي الغازات الخاملة, the inner gas. So they are, so each atom try to reach this stability, to have 8 electrons in the outer shell, so become stable and become less reactive. And this rule, like the tendency of the different atoms to reach this stability is called octet rule. Examples of the inert gas, like the helium and the radon. Here you can see this is the radon. It is one of the is very chemically stable gas, and it have, as we can see, in the first shell it have 2 electrons, in the second 8, in the third 18, then 32, 18. So in the outermost it have 8 electrons. So it is very stable. So the atom try to reach this stability by either giving up electron or accepting electron or share electrons. So there is 3 ways, like if an atom have 5 or in the outer or 7, so there is 3 ways to reach this stability. Either giving away electron or accept electron, and the third way is to share electron with other atom. Then the atom will reach stability. There you go. Not?
Not save. We don't have to save the PowerPoint or slides.
Aha. I can send this to.
Something else.
Because I'm just covering this lecture for Dr. May, but I will discuss with her and will send this lecture to you.
Because there's more information that we have. There's more information that we have in our slides.
Aha. Okay. Yeah, but because this is what I have get from them, but we will discuss this with them. So for example, to show how different atoms reach the stability, one of the example is the sodium. Sodium have atomic number of 11. Okay, so in the first shell it have 2 electrons. In the second shell it have 8 electrons, and in the third it have only 1 electron. So 2 here, 8 in the second shell, and only 1 electron in the third shell. So for the sodium to reach this stability, is it easier to accept 7 electrons to have 8, or just to lose 1 electron? To lose 1 electron. That's exactly what happened for the sodium. So the sodium lose 1 electron, and then when it lose 1 electron, which charge will have, positive or negative? Negative or positive? Positive charge. And that's why here the sodium lose 1 electron, will have 8 in the outermost, will become stable, but it will become positively charged. That's why usually we write sodium Na+. For the chloride have 17 atomic number. So the first shell 2, the second 8, and the last shell 7. So what's easier to reach the stability? To accept 1 electron or to give 1 electron? Or accept 1 electron. If it's accept 1 electron, it will be stable. Which charge will have then the chloride? Negative charge. And that's why usually we write chloride negative, usually. So this is like the stable, the most stable form of this atom. While for the sodium, because it's easier to just give away 1 electron, it becomes positive. So after talking about the different constituents of the atom and how they are arranged and how different atoms try to reach stability by either sharing or giving or accepting electrons. We will go to the second part of this talk, which is the chemical bonds. In general, in biological system, we always have two kinds of bond, either covalent bond or non-covalent bond. So when two different molecules or two different atoms or two different particles interact, this interaction can lead to binding between these two molecules, and the type of bond is either covalent or non-covalent bond. So this is like the basic classification of different chemical bonds, either covalent or non-covalent. So we'll start with the covalent bond. It is the strongest bond. It's very strong. To break the covalent bond, you need a lot of energy. And that's why it's also called primary bond. So the covalent bond also called primary bond. So when atoms share electrons from valence electron, when we say valence electron, this means the electron in the outer shell. The valence electron is the electron in the outer shell. So when atoms, 2 or 3 atoms, share their valence electron, they create full shell four-port. So here we can see, for example, this is a kind of 2 different molecules. The 2 molecules, they have 6 electrons in the outer shell. For both of them to reach the stability, they can just share 2 electrons with each other. So every atoms will become 8 in the outers. And this bond, the sharing, when 2 atoms share the electrons, we call it covalent bond. So it is a strong, very strong bond. It's called the primary, and it the basic things in this kind of bond is that the different atoms share electrons. So the most common bonds in biological system is either the carbon-carbon bond. These are the most common, because I mean in our body the most available atoms is a carbon. So usually either carbon-carbon or carbon-hydrogen. So either carbonyl or methyl bond. So this is the most common covalent bond we have in the body. The non-covalent bonds, they are weak interaction between ions, whole or part of the molecules. So sometimes it is between 2 molecules, sometimes between different parts of the same molecules. To completely differentiate between covalent and non-covalent, you have to understand that in the non-covalent bond, it doesn't involve sharing of electrons. So here we don't have sharing. In the covalent bond, we have sharing of electrons. In non-covalent bond, there is no sharing of. So this is the major difference between covalent bond and non-covalent bond. And it's much weaker than the covalent bond, because in covalent bond you have like sharing of electrons, and that means the protons of the 2 atoms will attract the negative charge electrons. So this makes the molecule very stable, and the bond very stable. Regarding non-covalent bond, we have 4 different types. So in covalent bond, it's only one type, just sharing of electrons. Non-covalent bond, we have 4 different types. We have hydrogen bond, and we have ionic bond, and we have hydrophobic interactions, and we have what we call it van der Waals forces. So it is 4 different types of non-covalent bond. And all these different types, they doesn't involve any sharing of electrons. So let us go through them one by one. So the first one is the hydrogen bond. In the hydrogen bond, the attractive interaction of hydrogen with an electronegative atom. So usually the hydrogen have a positive charge. So when the hydrogen interact with electronegative atoms, this type of bond that is created is called hydrogen bond. So it's hydrogen with other negatively charged atoms. So here we have hydrogen, and here we have the negatively charged. So the bond here called hydrogen bond. Here is the same. We have hydrogen which have positive, and here we have other molecule with negative. So this force between the hydrogen and between the electronegative atoms create this bond. So it is attraction between the two molecules. One of them must be hydrogen to call it hydrogen bond. The other one must be electronegative atoms. So any kind of bond that contain hydrogen with electronegative atoms, this bond is called hydrogen bond. The other type of bond is the ionic bond. So the ionic bond basically is formed by attraction between two opposite charged ions. So one of the atoms donates an electron to become stable, as we have seen in the previous example with the sodium. It donates one electron to become stable, so the outer shell of the sodium will become 8. And this atom that donates or give away electron become, of course, positively charged, and we call it cation. So the cations are atoms that give away an electrons and became positively charged. The acceptor, the other atoms which accept this electron, will become negatively charged, and we call it anion. So this ionic bond is basically between cation and anion. One donates the electrons and the other accepts these electrons. And the example, like in sodium chloride. So if we came back here, this is a typical ionic bond. Sodium donates its electrons, and the chloride accepts the electrons, and then we have sodium chloride, the salt. So it is a typical example of ionic bond. The third type of this non-covalent bond is the hydrophobic interaction. So usually there is a non-polar part of the molecule, which is like water insoluble. So in some molecules, when they have, for example, two different non-polar parts, what happens when you put them within soluble media, they aggregate together. So the non-polar aggregate together, and they make like hydrophobic pocket. So this hydrophobic interaction between different non-polar sites is called, lead to formation or configuration of molecules. So the molecule, the shape of the molecule change because the non-polar sides aggregate together. So this interaction, we call it hydrophobic interactions. It is driven by this non-polar side of the molecules because they don't like water, they are insoluble in water, so they kind of try to hide from water, they aggregate with each other, and they change the configuration of the molecule itself. So this, we call it hydrophobic interactions. The first part, or the first type of the non-covalent bond, we call it van der Waals forces. This type of forces is very interesting because here it is not like interaction between positive and negative charge or sharing of molecules or this nonpolar. It occurs between two neutral molecules, like two stable molecules which have equal amount of positive and negative charge. So they are kind of less reactive. But what happened in this molecule that, for example, if you look to molecule 1, it has 4 negative and 4 positive charge. So it is neutral. And also, molecule 2 the same, have 4 negative and 4 positive charge. But what happened here, they change the configuration, so they distribute the positive charge and negative charge in different sides, and then they bound together with the opposite charges in the molecules, and this bond is called van der Waals forces. So it basically occurs between two neutral atoms due to the distribution of the positive and negative charge in a way that the positive charge from one molecule is facing negative charge of the other molecule. So this is called van der Waals forces. So we have covalent bond, non-covalent bond, or from the beginning, all molecules try to reach the stability. To reach the stability, they need to have 8 electrons in the outer shell. So while they are seeking for this, they interact with other atoms. So either they reach this stability by sharing the electrons with other atoms, as we have shown in the previous slide, 6 and 6, they can share two electrons, and they will become, everyone will have 8 electrons in the outers. So this we call it covalent bond or sharing bond. In Arabic, they call it al-ilaqa tasahumiyya, because it's every atoms gives the same amount of electrons to reach the stability. This kind of bond is very strong, and that's why we call it primary bond. The non-covalent bond is opposite to the covalent bond, as here there is no sharing of electrons. It's just either one molecule give electrons, other molecule accept, or it is hydrophobic interaction, or it is just between two neutral atoms, but they arrange their charge in a way that one molecule have a positive charge facing the other molecule negative charge, and then this interaction happen. So the non-covalent, either hydrogen bond, where we have hydrogen with other atoms, which should be electronegative, because for the hydrogen it have a positive charge. So any bond between hydrogen and between other electronegative, we call it hydrogen bond. The other one is the ionic bond. The popular example is sodium chloride, where one atoms, in this case sodium, give away an electrons, become positive, and the other atoms, and in this example it's chloride, accept this and become negative, and then we have this ionic bond. The third is the hydrophobic interaction, where two nonpolar parts of, for example, sometimes of the same molecules, because they are, both of them, they are water insoluble, they have a fear from water, they don't want to come in touch with water, so they aggregate with each other to avoid facing the waters, and this called hydrophobic interaction, fearing from water. The van der Waals forces, as we said, it happens basically between two neutral molecules. They have same amount of negative and positive charge, but they arrange this negative and positive charge in a way that the positive charge in one molecule is facing the negative charge in the other molecules, and then this attraction between the two molecules create what we call it van der Waals forces. Okay? We will have time for the question by the end of the lecture. So, in the third part of the lecture, we have what we call it common functional group. So, what is the functional group? We were talking about atoms, and then we talk about bonds between different atoms. Now, we are going a little bit more to talk about the molecules. In each molecule, we have the functional group. The functional group of each molecule is the site where different molecules can interact with each other. So it is a reactive site. For example, we have, when you have R the whole molecules, and this functional group is OH, the hydroxyl group. So if this usually found in alcohol or in sugars. So if these molecules interact with other molecules, the interaction will happen through this hydroxyl group. It is the same for the sulfur hydride groups. It's usually in amino acid. So some amino acid, like cysteine, they have sulfur groups, and through this group they interact with other molecules. We have also carboxyl group, COOH, and this found mainly in acids, and also in amino acids and fatty acids and whatever. We have also aldehyde group, COH. This we found it in sugar. So when sugar interacts with other molecule, the interaction occurs through this aldehyde group. We have also carbonyl group, also in sugar. They have carbonyl group and aldehyde group, and we call it also keto group. Then we have phosphate group, also in phospholipids and in nucleotides. So, because as I said from the beginning, understanding this basic stuff will facilitate your understanding when we talk about lipids, when we talk about sugars, when we talk about amino acids and proteins, when we talk about nucleotides. And then we have also the amino group. In amino acid we have amino group, which is NH2. So when amino acid interact with other amino acid or interact with other molecules, this interaction take place through their functional group, which is in the amino acid is the NH. It is amino group. And so all these concepts are important to understand how different molecules or different atoms interact with each other. So the most common biochemical reaction, we have 3 different types of biochemical reaction. We have oxidation reduction reaction, and we have condensation reaction, and we have hydrolysis. So regarding oxidation reaction, it's usually, for example, we have 2 molecules, A and H. Like this molecule have hydrogen with other molecule B. So this reaction, if it led to dissociation of hydrogen from A to B, so the AH became just A, and the B is accepting the hydrogen. So this we call oxidation reduction reaction. The molecule A, which lost the hydrogen, is the oxidized molecule. And molecule B, which accepts the hydrogen, so this is a very simplified explanation of oxidation reduction. When we remove hydrogen from one molecule, this molecule we call it get oxidized, and the molecule who received the hydrogens is became reduced. And it is reversible, so it can go in this direction and it can go back. So usually one of the main characteristic of the oxidation reduction reaction are they are reversible. So they can go in this direction and they can go back to other direction. The condensation reaction, that means you have 2 molecules. Molecule A, which have hydrogen, the functional group is hydrogen here. Molecule B, the functional group here is hydroxyl group, O and H. Here, to make these 2 molecules condensate, you need energy. And when they condensate, you will get molecule AB plus water, because this hydrogen and hydroxyl group, they give water. The hydrolysis is the opposite of the condensation. We have molecule AB. If we add water to this molecule, we will get the first molecule AH plus B with the hydroxyl group plus energy. So for condensation, you need energy, and it is unidirectional reactions, so only in that direction. For the hydrolysis, it is a reverse of this reaction, but it produces energy. So the same amount of energy that we have needed to condense these molecules and produce water, we will produce the same amount of energy if we add water to this molecule and we hydrolyze this molecule. So we go like more in details in this. So in oxidation reduction reaction, what happens is that we transfer electron from molecule being oxidized, which is molecule A, to the molecule being reduced, which is here molecule B. So molecule A lost the electron, so molecule A become positive, became oxidized, and molecule B accepts this electron. It became negatively charged, so it became reduced. So what happened to molecule A, which it lost electrons and became positive, became more oxidized, and the opposite happened to molecule B. So the oxidation and reduction cannot occur without each other. So they are coupled. So they cannot be oxidation without reduction at the same time. So both reactions should happen at the same time, because if one molecule give away the electrons, there should be an acceptor of this electron. So that's why both occur at the same time. One of the popular example of the oxidation reduction reaction are conversion of lactate to pyruvate. Here we have what we call coenzyme. You will get more information about this in the future. But this coenzyme is needed because they are acceptor of hydrogen. So the NAD positive receive the hydrogen, it become reduced. The lactate give the hydrogen to this NAD positive and it became oxidized. So this side of the reaction is oxidation reaction, and the other side of the reaction is a reduction reaction. So the condensation reaction, as we have seen in the previous slide, we remove water. We will have like two molecules, one molecule with a hydrogen group, the other with a hydroxyl group. When they condense together, and in this case we have propanonic acid and ethanol. So what happened? We get ethyl propanol plus water, because this propanonic acid had a hydroxyl group and the ethanol have a hydrogen group. When they condense together, you will get this ethyl propanol. You get this new bond, which called ester link or ester bond, plus water. So this is example of condensation. In condensation reaction between molecule which have hydrogen group, other molecule which have hydroxyl group, they condense together, and this reaction led to the production of water, and we need energy to this reaction. So here condensation of alcohol with acid to produce ester bond, and also the other example is between two amino acids. Also here the carboxyl group and the amino group, and this led to the production of what we call peptide bond. The bond between two amino acids called peptide bond. So the peptide bond here also is produced due to condensation reaction. The hydrolysis is the opposite of condensation. If you want to break the bond that you have produced with the condensation reaction, you just add water, and then the water will lead to the and that's why it's called hydrolysis, because it is the reaction that initiated by adding water. So breaking down of covalent bond by addition of water. This is the basic definition of hydrolysis. And it releases energy, as we said. The same amount of energy that needed to produce this bond is released when you break the bond. And as we said, the hydrogen and hydroxyl group added to the atom, and the bond is broken. Here A, B plus water, you will get A with hydrogen, B with hydroxyl group plus energy. So basically we have three types of reactions: oxidation reduction reactions, where one molecule give electrons to others, or basically if you remove hydrogen, we call it oxidation, and the acceptance of the hydrogen become reduced, the molecule become reduced. The second type is a condensation reaction. Two molecules with a hydroxyl group and hydrogen group. So when they condense, they produce different bond plus water, and you get new molecules by this condensation, which need energy. The oxidation reduction is a reversible reactions, while the condensation is not reversible. But if you add water, you can hydrolyze this bond, and this can produce energy. So three types of reactions: oxidation reduction, condensation, and the hydrolysis, which is the opposite of the condensation reaction. And here is the end of our lecture. So if you have any question? No questions? Either it is very clear or, yeah? Which what? When you add water?
How can I know which them take the hydrogen and which them take the OH?
You mean when you add? Usually, like,
Take the
because from the beginning, this molecule A, for example, in general, usually have hydrogen group. So to become like in its state, it needs hydrogen.
The A have more hydrogen, so I take.
Usually, the functional group of A is hydrogen. So as I said in the previous slide, that each molecule have different functional group. So A usually, the functional group for A is usually the hydrogen, while the functional group for B is the hydroxide. So when you add waters, each one take its functional group. So that's why.
حتى المايكرو حتاخذ اللي يكون عندها.
بالضبط كده. Thank you very much.